So what we're looking at today is we're starting to look at radicals, and a radical is this little, the little square root thing that you've seen before, but a square root is only specific to a certain kind of radical, so the generic term for this is just radical. That's what you call the little house-looking thing, okay? And depending on certain factors will depend on whether it's a square root or something, another kind of root, okay? So, but the generic term is radical. And what's important about this is you need to look at the number that's in the little v here. See how there's a little v right where my cursor is? Every radical has a little v, otherwise it wouldn't be a radical. And in that little v, there's always a number. Sometimes you're thinking, you're like, no, there's not always a number in there, but there actually is. And sometimes they'll write the number in for you, and sometimes there's no number that you can visibly see. So when that happens, and you have a radical where you can't visibly see what the number is inside the little v, the number is always 2. That's what this little purple starred phrase is telling you right here, okay? And this little number that appears in the v, we call that the index. So if you look in the little v and there's no index written, it means that there's a 2 in there. That's the assumed thing in there. Okay, so all the ones that we're going to be doing today, because the title of this is square roots, is going to end up being just 2. The index is all 2. So if you look at all the examples here, see how they don't have any number written inside the little flap there? It's because there's really a 2 in there. So to help us out, I'm going to write a little 2 just to remind us. And the index is really, really important because it tells us how to solve things, how to simplify these radicals. Okay, so let's start with the examples. I'm going to move on to the fraction part after I do the first 3 examples. So we'll split the lesson up that way today. Okay, so looking at number 1, my suggestion for simplifying the radicals is to pan them out to make them a factor tree. Okay, so if you look at 25, 25 can split into 5 and 5. Okay, and the index is important because it tells you how many of a kind you need to be able to leave the radical. So I refer to it as a house because think of it like this: you're inside the house, and to be able to leave the house, you need to have a certain number of friends to leave the house with you. Okay, so in the index tells you how many friends you need to be able to leave the house. So in number 2, the index is 2, so to be able to leave the house, you need to have 2 friends. Okay, so looking at this, we do have 2 friends. We have 2 5s. They're exactly the same, and that's the thing. The friends have to be exactly the same. So there's 2 friends of 5s. So because you have 2 friends, I circled them. That means that one person can definitely leave the house. So for every circle, every group of 2 that you're able to circle, one of the 5s can come out. Okay, and so there's a 5 that comes out of here, and because there was nothing left over after you circled, see how there were no numbers left over outside of the circle, then that's it. All your final answer is 5. Okay, so I know that's a little weird concept, the leaving the house thing, and you can only take one of them out. Yeah, for every circle group that you have, you can only take one of those numbers out, but and then if there's any leftovers that are not circled, you multiply them together, and then you just leave them inside the radical. Okay, so let's look at this. Let's look at number 2. So 900, let's split it up. Let's go, how about 9 and 100 here. Okay, so if I split this up, I don't want to change the color. There we go. So 9 can go into 3 and 3. 100 can go into 10 and 10. And you know what? I'm going to stop here. I know I can keep going with the 10, but why keep going with it? I mean, I need 2 of a kind. Here already is 2 of a kind of the 10s. Okay? So let's circle all of the 2 of a kinds I see. I definitely see a 3, and I definitely see 10s. Okay, so those are 2 of a kind. Again, it's 2 of a kind because the index is 2. So because I have one group of 3 circled, I can take a 3 outside the radical. I have a group of 10s that's circled, so I can take a 10 outside the radical. Is there anything left inside the radical now, or have I circled everything already? everything is circled, right? After I factored it out here, everything is circled, so there's nothing's going to be left in the radical. And what you do now is, because I have two numbers now that are outside of the radical, all you do is you just multiply the two numbers together. So here's the 3 that I was able to take out, here's the 10 that I was able to take out. I multiply them together to get 30. So final answer for this is going to end up being 30. Okay, hopefully a little bit better. Let's look at 3. So first step for this, you guys, is let's factor this out. I need 2 of a kind, so here's, let's go 4 and 2, 2 and 2, and then I'm just going to drag this 2 down just so it's lined up with the rest of them. So like I said, I need 2 of a kind, so here are 2 2's right here. So because I can circle one group, I can take a 2 out, okay? So there's a 2 out there. Is there anything left over that did not get circled? This guy, right? This guy didn't get circled yet, this 2 right here. So he has to stay at home because he didn't have a buddy to leave the house with him. So I have to redraw the radical, or I have to redraw the house. And because this guy didn't have anyone to leave the house with, he has to stay inside. So the final answer for this, the way you would say this, is 2 radical 2. So I'm able to put a 2 on the outside because I had one group that I was able to take out. Okay, so hopefully that's a little bit better. We'll kind of practice with these even when we get into the ones that have the fractions. Okay, so here's what's going to happen with these fraction ones, you guys. What they do is the book will give you these fractions, and then they'll put a big square root or a big radical over them. And what I'm telling you to do is, it should be automatic that when you see something like that, you separate the two numbers in the fraction, the numerator and denominator, and put them into their own separate radicals, or their own separate houses. So if you see a fraction, what's automatic is you should separate the two numbers, the numerator and the denominator, and then put them into their two houses, as you can see here in the purple up here in the second window on the top here. Okay, so let's look at this and let's see. So for number 4, here on the bottom, these are all the fraction ones. So I see a 64 over 169 underneath, a big radical. So the first thing that I'm going to do is I'm going to separate them out into their own little houses here. I'm going to scroll this down so we have a little more space. Okay. And then all you do is you do the same thing that we did for examples 1 through 3, but you're going to do them now twice, or there's 2 different problems now. So on the top, let's work on this 64. What's the index for both of these, even though it's not written? Index is 2. Okay, so I'm going to write that in just so that we don't forget. And the index is really important, you guys, so don't take advantage of it, because later on the index may not be 2. So yeah, okay, so 64 splits into, remember we need 2 of a kind, so don't you think 8 and 8 would make sense to pick? Okay, here's a group of there's a group of 8s right there, so I can definitely take an 8 out, and there's nothing left over inside the radical, right, because both things got circled. So the top is just going to be 8. Now if we look at the bottom, 169, this one might be a little bit tougher, but if you're good with your perfect squares here, 13 and 13 both work, right? So there's a group of 13, 2 of a kind. That means I could take one out, nothing left inside the radical. So final answer for this is 8 over 13. Okay, very good. Okay, let's look at 5. So I'm trying to trick you. I'm trying to make this difficult, right? I'm making this difficult because look at the numbers in here. I put like 576 and then 1225. Something also that might have thrown you off is this plus or minus thing here. Let's write in the index for sure. And this plus or minus is not really significant right now. So all you have to worry about is just dragging it down till the end of the problem. Whenever you're done with the problem, just make sure that your final answer has a plus or minus in front of it. It doesn't really affect the problem in any other way. Okay, so I see a fraction here. So automatic, like I told you guys, is to do the 576 as a separate fraction, as its own number, do the 1225 as its own radical. Okay, and so if we work this out, I'll help you out here with this because they're large numbers. If you want to try it by yourself, go ahead. So here's all that we're going to do right now. So you can split the 576. So I'll help you out. Pause the video if you're doing this by yourself and you want to see what you get. So 576, if you want some help, maybe it can split into 9 and 81. And here's just a side note, you guys, so listen to this really quickly here. So it doesn't matter what you split this into, okay? So if you did like 2 and whatever 576 goes into when you divide it, when you divide 2 into it, doesn't matter what these first two stems are, you'll get the same answer no matter what you choose, as long as the factors you choose are correct that they go into it, okay? So I chose 9 and 81. If you did 2 and whatever 576 goes into, that's fine too. You'll get the same answer. So it doesn't matter what the first two factors are. Okay, so 9, you guys know, splits into 3 and 3. 81, you know, splits into 9 and 9. I'm not going to pan out 9 any further because if I need 2 of a kind, I don't want to waste time anymore panning that out. Okay, so here's 2 of a kind right here. So I can definitely take out a 3. And then here's 2 of a kind there, so I can definitely take out a 9. So like I said, I can take out a 3, I can take out a 9, and we're going to end up multiplying those two together, right? Anything that gets taken out and there's more than one thing. If you look at this, there's nothing left over inside the radical, so that's it. It's a perfect square. There's nothing that's going to be left inside. For the 1225, just to help you out, again, if you choose different factors, that's fine. It's not a big deal. You'll get the same answer still. So the 12 and 20, the 1225 can go into 25 and 49. Okay, and then 25 can go into 5 and 5. 49 can go into 7 and 7. And so, let's see, I got a pair of 5, so I could definitely take a 5 out. I got a pair of 7, so I could definitely take a 7 out. So now all I do is I just finish this out. So I have 3 times 9 is 27. I have 5 times 7 is 35. And then, remember this plus or minus, told you just drag it down to the final answer. And so, there we go, 27 over 35. Okay, so go ahead and see how you guys do with this. And I'm going to put the answer here for number 6. So why don't you go ahead and try and work out number 6 on your own, and I'll tell you what the answer is for number 6. So the answer for number 6 should end up being negative 6 over 13, I believe. Okay, so negative 6 over 13. If you do this correctly, it should be negative 6 over 13. So remember, this negative here is not meant to throw you off. All you do is you just drag it down to the bottom here. And then the index is 2 because there's nothing written here. And if you're looking at this and you're like, negative 6 out of 13, over 13, how's that going to work out? Remember that after you get this into a fraction form, I still want it as simple as it could be. So maybe you might have to reduce the fraction possibly. Okay, so try and simplify this out. See how you guys, if you guys are able to get the final answer. And don't forget to take the quiz.